Hey, it's Mr. Barr, and this is the Semester 1 Practice Final version A. Okay. Here we go. Base, add. So something plus 6 has to equal 13. 7 plus 6 is 13. That worked. Once again, this is not really a teaching video. This is just a quick go over it and give you some pushes in the right direction. How many times larger than 4 is 400? 400 divided by 4 is 100. Now apply that logic. This one actually will not be on the final exam. It's just getting you set up for the next one. How many times larger than, so this is the one that is this. I need to make that correction. So 3 times 10 to the 7th over 3 times 10 to the 2nd. This is 3 with 7 zeros behind it, 3 with 2 zeros behind it, cross out zeros. 3 divided by 3 is 1 with 1, 2, 3, 4, 5 zeros. So 100,000 times bigger. All right, so this one says start at 0, 0, go 12 units, and then where's the line? 0, 0, go over 12 units, go up. Where's the line? The line's at 6. Or how high is the line? At 6. Cool. Next one, find the error. Okay, so it looks like I have 9 to the 6 over 9 to the 2nd. 6 minus 2 is 4. 6 minus 2 over 1 is 4. Uh-oh. Nope. It should be 9 to the 4th. I have it as 9 to the 5th. It should be 9 to the 4th. Create the equation for this line. Well, I find a good point on the line. I draw on a slope triangle. This is 16 over 2. So my equation is y equals 16 over 2x, which simplifies to y equals 8x. Another exponent 1. Okay, so this is 4 to the negative 4 times 4 to the 5th, which becomes 4 to the 1st. There's 4 to the 1st raised to the negative 3. 4 to the 1st, power multiplied, it becomes 4 to the negative 3. There's a ticket brings it down to the bottom, so 1 over 4 to the 3rd. The other way to think of this is kind of like a distribution. It's not really a distribution, but it looks like a distribution. So this would be 4 to the 12th times 4 to the negative 15. So 4 to the 12, 4 to the negative 15. So here are all the different iterations of this. Let's try to match it up. So 4 to the negative 3, yeah, that matches up with something I had. 1 over 4 to the 3rd, there it is. And 4 to the 12, 4 to the negative 15, 4 to the 12, 4 to the negative 15. I got that because of that kind of, it looks like distribution, but it's not distribution, that piece. Okay. So here's an equation. I solved it. I ended up with 9 equals 13. What does that mean? There is no solution since 9 equals 13 is false. Okay. 9 equals 13, 9 equals 8, false, no solution. Find a value for x that would make this true. Okay, so if I plug in x equals 1 gives me 3 over 9, which is 1/3, which is not 1/9, so that one doesn't work. If I put a 2 into it, I get 9 over 81, which is 1/9, that works. So what does work? You know what, I have this written backwards, so let's fix that. So what does work? Find a value that does make it work. That's a 2. And what doesn't work, 1, which would basically be anything but 2. There you go. Anything. A 2 works. Everything else doesn't work. Okay, that's good. Find the relationship here. Okay, proportional relationships are y equals mx plus b. So, or actually y equals mx plus 0. And notice that's the only one that's in that form, y equals mx plus 0. All right, let's solve this equation. I'm going to start by distributing the 1/2. So half of a is 4, half of negative 6 is negative 3. There's the distribution. Combining those two guys to become a 6x minus 3. Adding 3 to both sides becomes a 30. Dividing both sides by 6 becomes a 5. Rainbow poster. This one, combining terms, 5x and 3x is 8x. Negative 4 and negative 8 is negative 12. Let's add 12 to both sides. Boom. That gives me negative 16. Dividing both sides by 8 gives me negative 2. One box can hold 24 apples. How many boxes for 480 apples? So 480 divided by 24 is 20. Division. Okay, that's not on the test. It's just setting you up for the next problem. Now I have 7 to the 7th apples divided by 9 to the 7th apples divided by 9 to the 4th apples. So I have 7 9s on top, 4 on the bottom. That gives me 9 to the 3rd boxes that I'm going to need. It's the same problem I just did, except with exponents. Select all the equations that have infinite solutions. Infinite solutions means that they're going to be same on both sides. So 13x plus 7 is not going to be the same as this guy if I distribute and add. If I, see, this gives 6x plus 3, no, excuse me, 6x minus 42 plus 3. Negative 42 plus 3 is the same thing as the negative 39 on the other side. This one does work. Right here, if I distribute that 2x and simplify it, it does work. And here, subtracting 4 minus 10. This guy, I distribute, I simplify. That one doesn't work. This next problem isn't going to be on the test. It's just setting you up. How many times more people went to Disneyland? So 64,000 divided by 800. Here's a way to do it. Oh, my lights. Okay. 64 divided by 8. Wait, I can cancel out 0, 0, 0, 0. So 640 divided by 8 is going to be 80. Same idea comes up now. And I did this a different way on a different video. What's 12 times 10 to the 9th over 4 times 10 to the 3rd? Good. What's 12 divided by 4? 3. And what's 10 to the 9th over 10 to the 3rd? Well, there are 6 on top times 10 to the 6th. This is the same thing as 3 with 6 zeros. 1, 2, 3, 1, 2, 3. Okay, 18. Okay, filling in the table, remember you add down, so 40 plus 110 is 150. You add across and make it work like that. Scatter plot. Where is the intercept? Well, the intercept is right there. I have that as 75. Can I zoom out? And then I went with this whole thing for my slope triangle. Looks like it's about 6,075, and it's a negative, so 75, negative 75 over 6,000 gives me that number right there. Let's do it again. This one, the intercept's at about 20. There's my intercept. There's a good point. Slope triangle, 40 over 20. My slope is 40 over 20, which is 2. There's my intercept. Excuse me, not my intercept, my slope. Movie theater, okay, I can either pay 12 bucks a ticket or I can buy a card and then pay 8 bucks a ticket. When does it match up? Matches up right there at 4 movies. 2 equations. They're both in standard form. I take the standard form, split them into mini equations. I plot the intercepts and I draw the line. Standard form, mini equations. Plot the intercepts, graph the lines. Looks like it comes together at 4, 0. Jonathan is deciding between cell phone companies. These are both linear equations. So both cost models are linear. That's true. The 2 graphs will not intersect. Well, they will intersect because they have different slopes. That's the slope, the change. Company B will always be cheaper. I don't know. It depends on how much you talk. You can only determine if you know the number of minutes. Okay. 24. Okay, so this one's in standard form. I turn it into 2 mini equations and I plot it. This one's in slope-intercept form. I start at -4, go up 2 over 1, up 2 over 1. Comes together right there at 3, 2. And I need to say there's one solution at 3, 2. This next one. Okay, so I had to make a change. It should be correct on your version of it. Infinitely number of solutions means that this guy and the other guy have to be identical for infinite solutions. Exact same linear equations. They're right on top of each other. So 2x minus 3y equals 6 equals 12 over here. That one doesn't work. 2x minus 6, no, that doesn't work. So if I take letter C, which is, let me take C. I'm going to set over here. 3y minus 2x equals negative 6. Let's switch the x and the y, so 2x plus 3y equals negative 6. Still not matching up. Let's change all the signs. 2x minus 3y equals 6. Now it does match up. That's the one that works. It's the exact same equation. It was just given to you in a weird form. Another scatter plot. The intersect. Look at this guy. If this is at 5, this is at about 4.5. I have it at 4.5, 4.5. The slope, good point. Slope triangle, 6 over 4, which is 1.5. Slope is 1.5. Let's see, this guy is in standard form. They're both in standard form. I split them into 2 mini equations. I solve each mini equation, and then I plot the lines, or plot the intercepts, and draw it, and it looks like this came together at negative 2, 3. Notice it's asking for the x-coordinate. The x-coordinate is at negative 2 right there. Okay, this one, yes pizza, no pizza. Yes tacos, no tacos. 74, once I get that no tacos, no pizzas right there at 74, I can fill in the rest of the table because I know they have to add up to the totals. If I'm missing one of these, I'll subtract it from the total and figure it out that way. Okay, this one is only relevant for integrated math. Math 8, I didn't teach you this. So I have my 2 slope-intercept equations. I set them equal to each other. So I have my 2 equations equal to each other. I'm going to subtract x's from both sides. And then I'm going to subtract that from both sides. I'm going to divide both sides. It's all rainbow poster, but with decimals, crazy decimals. And then I get 8.82, but I have to round it up to 8.9 years, because if I round it down, then the population won't be big enough. And finally, let's see, what's true, false, or not true? Okay. 2 lines that have different slopes will never intersect. No, different slopes always intersect. 2 lines that have different slopes will never intersect. No, that's false. 2 lines that have different slopes never intersect. That's false. They do intersect. 2 lines that have different slopes will intersect at exactly 1 point. Yes, that's the true one. They will intersect at 1 point. 2 lines that have the same slope will intersect at exactly 1 point. 2 lines that have the same slope. Now, same slope will either be parallel, where's my camera? Parallel or infinite. Well, parallel or coinciding. So that one's false. 2 lines that have the same y-intercept intersect at exactly 1 point. And the thing with that is, it's right here. Okay, so that's a pretty bad bit. That makes it look like it's 1 point, but look, if I just keep turning this guy, it could be 1 point or it could be infinite. It could either be 1 or infinite, 1 or infinite. So I put a little note there. It could be infinite, so that's the sometimes. Okay, is that it? Cool, that was practice A. Thanks for watching, bye. Where's my cursor?